Okay, I wanted to do a little video on a battery monitor for 12 volt systems in an RV. These things run a couple $100, and some people seem kind of confused about what the advantage of something like that is over the little battery voltage kind of meter that typically comes on your RV. And basically, when you look at the charge profile for a lead acid battery, a battery will go into what they call bulk charge mode when a charger is activated, and essentially the battery in that situation, say if you really ran it dead down to 11.5 volts or something, you shouldn't discharge it that deeply, or say you left something on in a car and the battery was dead. The charger will put out full power up to its amp rating. If it's a typical 12 amp car battery charger, it'll be sitting there putting out 12 amps. And as the battery becomes more and more charged, it will eventually reach what they call bulk mode, where the charger will limit the voltage supplied to the battery. For cars, starting batteries, they typically go to a bulk voltage of like 14.1. Deep cycles require a little higher voltage, typically 14.4, 14.8, right in there. Like the L16 super tall Trojan batteries actually require a higher voltage, but the charger will hold, say, 14.4. And as the battery becomes more and more charged, the amount of current that the battery will absorb at that voltage will naturally taper off. Pardon me. So when the charger is in absorption mode, it's going to hold that same voltage, but you don't know if it's almost 100% charged. Is it 70% charged? What status is it? The other thing is, say you've got, I've got a TriStar remote here for my charge controller, and of course it'll tell me how much power my solar system is putting out. But that doesn't mean that that's how much charge my batteries are accepting, because typically I've got some loads on at the same time. So what a battery monitor does, it uses a shunt, which is basically has a very precise resistance. You might have a shunt with a 500 amp current capacity. That with a 500 amp load gives you a 50 millivolt drop between the two lugs. So you'd have your battery bank connected to one side and all negative loads, everything else that goes to the negative side connected to the other. And if it sees a few millivolts one way, it knows that a certain number of amps are going out of the battery, or if the potential is the other way, then it sees that a charge is going into the battery. So it can basically track the amp hours, or they'll usually also display watts going in or out of the battery. So some are set up so that you can program the amp hours of your battery. If you know that you have 200 amp hours worth of battery, you can enter that, and the computer that's looking at the voltage potential and determining the current going in or out of the battery can then calculate a percent charged. Typically you may be able to manually set the battery monitor to know when the battery is full charged. But they'll also, some of them, I had one that you could set the battery percentage of efficiency. So, if you pulled out 85 amp hours of power from a battery, it might take 90 something or whatever amp hours going in to bring it to full charge, because there is some, the batteries are not chemically perfect. There is some loss. the other way that these will, the computer in these will generally trigger itself to knowing that it's full charged. As you're in that absorption state, say holding 14.4 volts, and the current drops and drops and drops, when it gets down to a particular very low current and maintains that for a period of time, then the battery monitor will determine that the battery is charged. So in the past, you'd have a shunt like this without any electronics on it, and volt sensing wires had to be twisted pairs and generally shielded that ran to the monitor that held all the electronics. Since you're looking at microvolts to measure, you know, a tenth of an amp or whatever the accuracy is, any magnetic fluctuation fields from any other cables would be enough to muggy up the accuracy. So now this one actually has a circuit board printed on it, which eliminates the need of those wires being shielded and the inaccuracies that might come from that. So it does its measuring right on the circuit board on the shunt. Means you probably don't want the shunt in the battery box, or certainly not anywhere out in the weather, but all you have is just basically a data cable there that runs to the display that you can mount in your panel. The other super cool thing this has is Bluetooth, so you can use a phone app to monitor the charge level of your battery wherever you want. And also apparently you can set it to say give you an alert when your battery gets below a certain charge level. Lead acid batteries, people say you can't discharge them below 50%. Well, you can, but it doesn't make economic sense to do that very often. If you have a 100 amp hour battery and you're using it constantly every day, you're drawing it down to 50%. It's much more economical if you were to double the battery bank size and just draw the battery down to 75% discharge all the time, because you will get, you're buying two batteries obviously and doubling the cost, but you will way more than double the life cycles of the battery. So you get a lot more amp hours stored per the life of the battery per dollar by keeping your depth of discharge less than 50%. And the other thing that I think you see some confusion about, people say, oh, lithium, you can discharge 100%. Well, not necessarily without reducing its life. Lead acid batteries like to be stored fully charged. They don't build up sulfides like that. Lithium batteries don't like to be at full charge, especially if you hold them at 100% in very high ambient temperatures. You end up damaging, reducing the efficiency of the battery. They degrade. So here, where we can hit 117, whatever in the summer, unless you have them in a temperature controlled environment, that could be detrimental. So anywho, in my particular little tow trailer here, I've got a battery box on the tongue of the trailer. I've got my solar charge controller into the closest out of the weather spot that I could go to the battery charger, which happens to be, there's a little side storage compartment and a side wall of the water heater compartment. So that's where my charge controllers and stuff are mounted. The inside of the belly of the trailer is really well sealed, and it was really a pain to fish cables from the charge controller back. I think I ran either 2 or 4 gauge cable to have absolute minimum power loss between the battery and the charge controller. So I basically don't want to tear through that again, so I'll probably pull the negative lead off the charge controller and then put a ring terminal on it at the appropriate length, and then put the charge controller and the battery cable for this trailer. You know, they're typically used cheap. I think it's a 6 gauge, just a cheap wire running to the ground bus that also connects to the charger converter that's part of the power distribution box in this small trailer. Cheap setup. So rather than dig the insulated underbelly of the trailer apart to run a cable from this shunt over to the power box, I think I'll actually, if you look in the bedroom here, right under there is the hatch that goes to the water heater. From there, there's an opening for cables and wires under the tub, and there's the access hatch under the shower. And then I can just remove my power distribution center here, and right behind it is the main negative bus bar. So I think what I'll do is I'll just run a new 4 gauge cable from that negative bus bar through under the tub and over to my shunt, and then I'll just disconnect the existing negative battery cable that runs from the bus bar to the batteries on the tongue, and that way I won't have to tear anything up. I figure I'll be stringing the data cable from where I intend to mount this by the water heater under the tub. If I pull this panel out, I can then fish it through my wall quite easily, where I intend to mount this next to the rest of my controls. I'll probably, here or whatever I decide to do. So as long as I'm doing that, it'll be simple to just drag a new and better, nice piece of welding cable through there. The one thing about the display on these, it has a little threaded ring. So it seems like you kind of have to have access to the back side of the panel when you install it. You can't, reach in there and be able to put that ring on. But I think I'll be able to just, I'll remove this surface mount TriStar controller real quick, and I should be able to reach in and put the nut where I want it to put the battery monitor in. I meant to mention too what comes in the box. You get the shunt, the display panel, a little bezel that's optional. I'll probably use it just because the rest of my items there are square form and it'll look a little more uniform. And you get a couple of fused wire leads. These provide volt sensing. You can see the two little provisions to attach those. They sense the battery voltage and also provide power to the circuit board here. And then you've got this quite long cable. So it comes with two. So if you have a motorhome, you could send one of these to the vehicle starter battery. It won't give you percentage charge accurately because just your house batteries typically would be what you want through the shunt, but it will allow you to display the voltage of that secondary battery, which would be handy. You can at least have a rough idea of what your starter battery condition is if you're going to be camped someplace for a long time. Okay, dug through my bag of stuff here, and I found myself some 3/8 diameter nice solid copper lugs for number 4 cable. I've got my crimper here. Hammer blow crimper is just fine, but I have this, so I'm going to use it. Good wire cutter, some of the nice double thick heat activated adhesive kind of shrink wrap, and I had a couple of pieces of number 4 cable, so I'll put an end on the small one, and that'll be the one that runs from the load side to my existing charge controller, and the long one I'll put an end on, and that's the one I'm going to string back to the negative bus bar where it ties in with the power distribution center and its built-in little charger converter. And so there's my battery bank. Obviously when I get to doing electrical connections, I'll disconnect that. Some folks get the idea that 12 volts is safe to work around because it's not likely to electrocute you, but there's a tremendous amount of current there, so if you short circuit something, you can literally weld with it or set things on fire. So you really want to be sure and remove the negative cables and isolate them before you monkey with any of this stuff. And then here you can see the little board I mounted for my charge controller, and the circuit breaker for the panel input, and a circuit breaker to the positive side of the battery there for the charge controller. And you can see the negative lead there coming up from the opening in the floor behind the water heater that runs to the battery. And that's the one I'm just going to make my main negative battery terminal, or battery cable basically, and disconnect everything else from the battery and run everything through the shunt. And you can see I'll just snake it around the water heater. Like I mentioned before, the tub is right there, the shower, and it has access to string wires through it. And here you can see is the fridge, and below it the furnace is on one side, but the power distribution box is directly alongside it, so it'll be really easy to just run that cable through there. Just run the data cable and a new negative battery cable through there all at the same time. Let's see. I've got those crimped on there and heat shrinked quickly. Little tip that I learned, I would often use like Nolox or some sort of anti-oxidizing compound. Well, I'm used to putting things into screw down kind of attachments. You don't want to use any compound like that for these. The reason being, you can compress that copper into the copper wire and actually weld fuse it together, as long as there's no grease in there. And then also with a nice close-in connection, which I'd highly recommend so you don't get corrosion starting in on the wire. And the nice heat shrink, the thing is sealed from the atmosphere totally, so you don't need the oxidation protection, and it prevents you from getting that cold weld fusion. The other thing I'd mention, if you use one of these cutters, if you just do this periodically, there's no reason you can't use a knife, and be careful, one of these is safer. If you're used to using one of these on like residential kind of wiring, not on welding cable, it's super flexible. And I generally want the tension dialed down to the minimum, and I'll just do one wrap around and pull it off from there. The strands on this stuff, are quite fine, and that's great. It makes it super flexible, but it's can be really easy to accidentally cut strands, and of course you want to get all the strands not cut and neatly tucked into the terminal just to do a nice job. So there's that. This crimper is a Temco. It's one of their factory refurbs, which can be an affordable way for the occasional person that installs winches or whatever to get a nice crimper. Of course, with this, it's designed for much larger wires, so it's really easy to over smash something with it. Probably not best practices, but I find it's handy to start a crimp on one way and then turn it and finish the crimp the other way. You don't want to over smash one of these and extrude little edges of copper between where the jaws meet. They call that winging, and it weakens the strength of the connector. But I find if I just slightly push them in one way and twist the axis, then I get super tight connection. You can clamp that in a vise and try to yank it apart. It's really on there, but you don't get the winging problem, and you end up with a nice looking cable. Okay, not sure where I left off. So I unplugged my 110 30 amp power to shut down the inverter charger, shut down my solar charge controller, and then removed and isolated the negative cables. And then I went ahead and pulled the happens to be larger gauge in my installation, but the battery cable out of the solar charge controller, and that's the one that'll get a ring terminal on it to connect to the battery side of the shunt. That'll just become the main battery cable, and then I'll make a little jumper from the ring terminal to the screw crushed kind of terminal there on the charge controller. And for my application, just some sheet metal screws, appropriate size pilot hole drill, and get the shunt mounted, and then I can figure out how much and at what how much cable and what angle I want the lug for the battery cable, and then of course install and cut the lug that goes over to the charge controller, and on that same lug will be the cable that I'm going to run to my negative bus bar that powers everything else. Everything's labeled on here. These say B1 and B2, and they're just little push down deals. They came with a little ferrule crimped on the wire, which was a nice touch, and then of course the data jack just plugs in, and then your cables go on here. The one says battery only, so that's everything going to the battery, and then every charge source and every load will go on this lug so that it can measure everything coming in and out. So don't forget, if you have a tow vehicle or any other source of power too, to disconnect it before you start monkeying with wires. So we've got the solar shut down, the shore power shut down, and no vehicle connected. Okay, so there's that all connected up. See, I've got what had been the battery cable is the one on the right. Had been the battery cable negative running to the charge controller. Now it's just the battery cable running to the shunt. And then those two other pieces I've put connectors on. One just ran back up into the negative strain relief there of the charge controller up into the negative block. And the other is this piece that I've got strung out. It'll go to the negative bus for all the loads and for the internal charge controller, everything else. And then my wire for the meter, I've just got taped to that to make it easier to pull through. And I'll just poke a hole through that foam there and pull it into the hot water heater compartment, and loop it on through back by the power bar. Okay, under the bed here is the water heater axis. There you can see the shunt passed everything through here. And just string it out here, and there's an opening there. But the plumbing and factory wiring passes through along with a little bit of heat. And there's that access hatch there, so I'll just run a snake through there and grab that. And then I'll get this model airplane out of the way. And if you open the power panel, there's a couple screws that just hold the front bezel on, and then you'll see 4 screws that kind of hold the main unit in. You just kind of tip it out of the way. And that also, you can just reach around, and there's access into the bottom of this wall. And I'll also have to cut a hole there from I've just got my wires pulled through there and straight out on the floor for right now. That's what the power panel looks like after you just take out those 2 screws, and the whole outside just tips and then unhooks. And you can see the stock charge unit there, and then the alternating current and DC breakers. Okay, I got those 4 screws out, and you can see that negative DC cable. The top part of this box is DC. That runs in here, it noodles around, and it attaches to that neutral bar, and then the negative battery bar, and then the other heavy lead there is the stock cable that comes to the battery, and that's the one that we're going to replace with that wire we're fishing through. I may go ahead and get rid of this really stiff wire too, but I haven't decided yet, as long as I'm in here. Okay, so here's what that looks like installed. I went ahead and put it above my dooflingy there. It's easier to see if you're taller. Connected to a Bluetooth, gave it the amp hour capacity of my battery. It's plugged into shore power right now, but it'll give you voltage. That's the auxiliary battery that's not connected. 1.36 amps is coming in off my shore power, or 18 watts. And it's showing amp hours and percentage full is probably where I'll just leave it. I think we can set it for backlight to timeout and that sort of stuff too using the app. It did make me do a firmware update. While I was in there, there's a piece of wood across here to support the vent pipe for the black tank, and you know, they could have just put a little stick of wood in there and support this. So I went ahead and did that. That way you could push the buttons without the whole wall buckling, which is just kind of a tactile reminder of how flimsy these things are built. But anyway, there it is. Everything's cleaned up back together. It seems to be pretty handy. I set the Bluetooth to alarm whenever it goes below 50% charge. Okay. So yeah, now we're pulling 6 watts, and you can go on through the app and tell it not to monitor the starter battery since it's not on there, and I think I had it not toggle through amp total consumed. I basically want it to give me percent charge, voltage, amps, and watts going in and out. So now I have that easy to just find what I want to look at. And then the other thing, I figured out why I have to push so hard on this stupid thing. You can see the circuit board's supposed to be little buttons are supposed to be held to the face of that by that little clip that's deformed. So I think I'll see if I can't get a zip tie or something to hold that in place. Pretty cheaply built thing, but I really don't feel like buying another one. Anyway, I hope this video was helpful to anybody. I think this Victron unit looks pretty handy. Doing just the Bluetooth version would save having to string a wire up through here, but I kind of like having the monitor, you know, there with my solar and my furnace control and everything else right there, because I don't always have my phone, especially when I'm in an area with no service.